Alright, so there's two types of symmetry that we're going to talk about today. One is line symmetry. And this is a symmetry that we are used to learning about, especially like in art class or maybe when you're in a younger grade. We talk about that symmetry, that things are symmetrical. Does anyone remember what does it mean to be symmetrical?
Are there any leftover notebooks?
It would be in that bin, but I don't think there was for this class. What does it mean to be symmetrical? Or to have symmetry? Oh, did you find it? Cool. You guys are crushing it. What animal is really famous for being symmetrical? Like, what's an animal that you could like make on one side and that's on the other side? Butterfly. A butterfly is symmetrical. You guys are so awake today. Crushing it. Alright. An object is reflected onto itself, so it's like it can be folded over. So part of you is the exact same part as the other half or the other part. Alright. So right now, computers can be set aside. If you have your computer out, you should have your notes out. Computers can be set aside. Computers can be set aside. Computers. Fire out. Get your notes out. Notes. Okay, you can do notes and click that at the same time. It's amazing. Your body can do two things at once. It's crazy. Alright, so line symmetry is an object is being reflected onto itself. Alright, reflected is another way that we can think about things being folded onto itself. So if we drew it on a piece of paper, we could like fold it in half and it would look the exact same on both sides. Letters of the alphabet, let's use C. C is a letter that has line symmetry. Where could I fold this C in half so that it folds up onto itself? Would I fold it in half vertically, like a hot dog, or this way? Hamburger, yeah. So this would be our line here. If I folded that down, that C would be on top of itself. Okay, today we'll talk a little bit about this patty paper, but this patty paper is helpful because we can draw it on this patty paper, this C. And if I fold that C in half, you can see how on the patty paper it lines up with itself. It's the same on both sides. Okay, we call this patty paper. I don't know why. Oh, because it's called Dali patty paper. I don't know. Alright, that's our first one. This line that we draw is called the line of symmetry. Mathematicians, I'm telling you, are just the most creative people in the world. That was sarcasm because they just called it line of symmetry. Alright, next up we have rotational symmetry. Take out your notes. Get ready for class first. Yes. Class has started 7 minutes ago. Okay, so take your notes out. Get ready. Because you're going to have to do that when you come back. Rotational symmetry. You also can't go for another 3 minutes, dear. Is kind of a newer concept for us, probably. It's not one that we talk about necessarily in art class, but it is one that we're aware of. And rotational symmetry is okay, so for example, if we have a capital H, And I say that this is the top of the H and this is the bottom of the H. If I flip my notebook upside down, what's going to happen to that H? I physically take my notebook, I flip it upside down. What happens to that H? Nothing. What is it? What letter is it still?
A T.
What? A T?
I thought
Flipped it all the way upside down.
I, right?
If you flip it sideways, I'm just looking at it like this. What letter is that right now? H. I flipped it all the way upside down, not on its side. I just flipped it upside down. So if I rotate it, how many degrees is that if I flip it all the way upside down? 180. So if I flip it 180 degrees, it still looks like an H. But this time, that top is really down here. And that bottom is really on the top. But it flipped, and when it flipped, it looked like itself. It looks like the same thing. Okay? Big thing here is magnitude with rotational symmetry. You're going to be finding magnitude when we have rotational symmetry. Every object has rotational symmetry because for sure if we flip it all the way around, that whole circle, 360, it'll end up on itself. Okay, and magnitude is our smallest angle of rotation. Our smallest angle of rotation. Okay, and when we do that, we take 360 as the whole rotation. So it's 360 degrees divided by the number of rotations that we can make. (360) divided by the number of rotations that we can make. Alright, you're going to be getting a sheet of paper with 5 objects on it. It's going to look like this to start with. I don't have enough space for all of these 5 to fit on one page. So I cut mine so that 2 fit on one side and 3 fit on the other. So that it looks like this. Okay, so if you want to cut yours like that, you can and glue them in, or you can glue them in however you feel like is going to work best for you. So I'm going to pass those out. Go ahead and if you need your scissors, go ahead and cut those out. Get those in. I just restocked your bin, so there should be glue in there. There should be scissors. So pass those around. Every bin should have at least 2 glue sticks, if not 3. Have glue at your table. Another what? Another piece of paper? Yeah. Hi. Can you get what? Yeah. I was wondering what you were coming. She's already come out to eat all fast. I was like, she's not as fast. Alright, for here, I'll be quick. And then actually do your notes when you come back. Alright, so go ahead and get those glued in. Gonna find my glue. Alright, with your glue sticks, please be making sure that you're putting the glue back down before you put the cover on. It's really hard to wash off the whiteboards, so it would be really great if you can make sure those are there. Alright, I'm also going to be passing out this patty paper. Did I get you one, Isaac, when you asked for one? Okay, I just can't remember. I'm going to be passing out this patty paper. If you would like to use it, you can. I'll show you a little bit about how to use it. So if you would like some, you can. And during your practice, if you need another piece, you can use that. You might want to keep your scissors out to use that. Really, it's just tracing paper. Nothing fancy. For some people, it really helps. Some people are really good at this visually, and they don't have to use the patty paper. They're really good at just being able to see it. Alright, so we're going to get started in about 15 more seconds. This is the part where I'm going to be using those colored pencils. If you'd like to use colored pencils, or you might want to use a highlighter, you can use those. Yeah, it's on the bottom. Alright, so for this first one, I want to know, is there any lines of symmetry? Is there anywhere on this triangle where I could fold it in half and make it the same thing? Yeah, I could fold it right down the middle, right? Right in half. Okay, if you're not sure, you can trace it onto your patty paper and do kind of a dark tracing. And you can count the amount of folds that you can make in order to make that. If it's easier, you can cut it out just a little bit, just so it's a little bit easier to fold. And then you can fold it and see when does it line up on each other, when does it work. So if I fold it in half here, does the back match the front? Yep. So for sure down the middle there. So I'm going to use my pink to show that. There's my first line of symmetry when I draw on that line. Are there any other places where I could fold that triangle? What if I folded through that point here and kind of fold it sideways? Does that line up on itself? Yep. So that one works. I can fold it this way. Is there any other ways I could fold it? Yeah, the other vertex. If I fold it through that other vertex, again, you can see in the patty paper it's a little bit easier when you do it yourself. You can see that it lines up because there's nothing sticking out. This patty paper is a little bit see-through, or you can look on both sides. Yep, it's the same. And so those are our 3 lines of symmetry in this one. So this one has 3 lines of symmetry. Alright, and then I want to know for rotational, does it have rotational symmetry? So this is again really nice where we can use that patty paper to put over it, and we can rotate it on itself and see, does it ever line up exactly on itself? So if I put this there and I rotate it, does it ever turn into the exact same shape? Oh, there it did. Oh, it did it again. And then it does it again at that 360. So you can kind of see in that background as it lines up that rotation that we could have tipped it over on its side. So how many times could I rotate this? So I'm going to start here. This is my starting edge. I'm going to think about this in my lower left right-hand corner. If I rotate it, it's going to go around once, twice, and then it goes back to its original, which is 3 times. Thank you. Okay, so it goes around once, twice, 3 times. It could be rotated. So there is rotational symmetry. And for our rotational symmetry, we need to figure out what is that magnitude. So we're going to take 360 degrees, which would be all the way around, and divide it by how many times could we rotate it? 3. So 360 divided by 3. Oops. 360 divided by 3 is 120. So this has a rotational symmetry of 120 degrees. When Farhia comes back. Alright, let's go to this other triangle. It's still a triangle. Let's see if we have the same amount of rotation and the same amount of lines of symmetry on this one. So again, if it helps to draw it on that patty paper, you can. So you just put the patty paper over it, you just trace over it, and then kind of cut that out, because that might help to fold it. Doesn't have to be anything fancy, if that helps you. This might help you visualize where can we fold it in half in order to make that symmetric line. Where can I fold this triangle in half to fold it over on itself? Yeah, right down the middle. So I'm going to use my pink to show that right down the middle. That's my one line of symmetry there for sure. So if I fold this over in half down that middle, you can see how the back and the front, they line up on each other. So, yep, right down that middle. Is there anywhere else where it folds in half? And the other triangle, it folded in half across that other angle. If I fold it there, is it going to end up on each other? You can see the other one behind it is back here, so that one wouldn't work. Anything else? I think that's our only one, is just that one down that middle. So this one has how many lines of symmetry? 1. So this is one line of symmetry. And we drew that line in. Now I want to think rotational. So I'm going to be just placing it right on top, and I'm going to think, is there any way I can rotate this so it ends up right on top of that original? So I'm going to rotate. Does it look like that original yet? Like it didn't move at all? No, no. If I flip it upside down, does it look like it? No. No, no, no. Oh, there it does. How many degrees did we have to go around that to make it look exactly the same again? Yeah, we had to go all the way around. Was there ever a point in that rotation where it looked the same? Just at the very end. So every time we have a shape, there is rotational symmetry. We would just take 360 and divide it by how many times could we rotate it back around before it looked like itself. Just that one time. And what's 360 divided by 1? 360. 360. I said that's so weird. So every time there is going to be rotational symmetry. Go ahead. Okay. If it's 360, that just means it can only rotate once all the way around. And if you want to draw that with your brown, you can, or your other color that has to go all the way around. You can. So it only worked all the way around. We had to rotate that whole thing over. Alright, we have 3 more. Hopefully as we're getting the hang of this, we're kind of ready to talk more maybe about it. Alright, so next up we have this shape. Does anyone remember what do we call this shape? We learned it in chapter 6. Starts with a P. Ends in parallelogram. Oh, parallelogram. Good job. Parallelogram. Alright, so here we have a parallelogram. And we want to know, is there any line symmetry? Is there anywhere where I'm going to be able to fold this where it lands back on itself? What? In half? Okay. So if I fold this in half, again, using that patty paper might be helpful. You visually see that. Does it actually line up if I fold it in half? No, it doesn't, because this corner is up here and that corner is down there. So not that way. Diagonally? Okay, what do you mean? This way? That diagonally? No. What about horizontally? No. There's no way that we're going to be able to fold this one where it lands up on itself. So this one has no line of symmetry. This one has no lines of symmetry. There's no way where we're going to be able to fold this where it looks exactly the same. It's going to always just kind of be a little off. Doesn't work at all. Which is crazy. You would think that, like, you could maybe get it to work, but no matter how you fold it, it's never going to land back on itself unless we twist it. Twisting is not symmetry. Alright, what about rotational symmetry? Is there anywhere where I can rotate this and it lands up on itself? So as you put it over, you can think about rotating, rotating, rotating. Doesn't look the same. Oh, there it lined up. And there it lined up again. So if that's hard for you to tell, did we make it all the way around or not all the way around, you can always mark somewhere on your paper. Like I'm going to just say this is the top. That's where I'm starting. That's my top. I can rotate it and see, is there anywhere else where it lines up where that top is not where it started? Oh, right there. It was on the bottom now. So that's 1, 2 times. So it rotates around 2 full times. So we're going to do 360 divided by 2. And what do we get for 360 divided by 2? 180. So our magnitude for this one is 180 degrees because it rotated around 2 times. Again, if you need to show that so that you can see it visually, you could draw in those arrows showing how you rotated it 2 times. Doesn't quite make as much sense as it does to actually use that paper and flip it over and see that it rotates. So you should have that paper on your, if you need it. Alright, we have 2 more. Next up we have a heart. Do we have any line symmetry with a heart? Yeah, in the middle. When you learn how to make a heart, like maybe in 1st grade or 3rd grade, usually your teacher tells you to fold your paper in half, right? And then once you have it in half, then you cut it out and it makes that heart. Okay. So we have it right down the middle. Is there anywhere else in this heart where I could fold it in half and it would end up right on itself? If I fold it this way, does it work? No. What about diagonally? What? No. The only one that works is right down that middle. That's the only way we're going to be able to get it right on top of it. So using that patty paper to actually fold it can be really helpful for some people. Some people are really great at just visually seeing it. So we have one line of symmetry. Okay, then we can think about rotational. So rotational, again, using that patty paper can be really helpful because you can hold it over and actually rotate it and see how many times does it line up. Again, if you need help, you could always label the top or the bottom. I'm going to label my top here so that I know once that top reaches the top, it's been all the way around the circle. So does it look like the same heart? Does it line up perfectly? No, 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 no. No. It only lines up perfectly when that top is at the top. So how many degrees did I have to rotate it before it landed back on itself? All the way around. So this one is a 360 degrees. We don't need to take the time to write 360 divided by 1. We can just say it was 360. It had to go all the way around. Alright, we have one shape left. This time it's kind of like that medical cross. It looks kind of like a four-way stop, those of you that are driving. Again, this one especially, I'm going to use that patty paper because this one has a couple surprising things about it. When I use patty paper, I like to trace it first, and then I just cut it off so it's a little bit easier to fold. Alright, so first off, where do we think we can fold this one? Where do we have a line symmetry? In half down the, like vertically or horizontally? We could do both. Let's start with vertically. So if I fold it in half vertically, I didn't trace it perfectly, but yep, it folds onto itself, and I can tell that because there's nothing else on the outside. Okay, what about if I fold it in half horizontally? Does it end up on itself again? Pretty much. Again, I might have drawn it perfectly. So it can go in half this way. Is there anywhere else where we're going to be able to fold this, where it would end up on itself? Yeah, what if I do it diagonally? Does that land on it? Yep. So if I go between here, that would end up on itself. Okay, and if I flip it on the other diagonal, it actually ends up back on itself again. So how many lines of symmetry does this one have? 4. So this one has 4 lines of symmetry. Alright, and then with that rotational, this is one that it might get a little confusing, especially if you don't recognize where is your top or where is a certain part. Again, I always like to just mark where my top is. That way I know when I've made it 360 degrees all the way around, I can stop counting. Otherwise, sometimes we get caught in this loop where we just keep counting and counting and counting and counting and counting and counting, so we don't know when to stop. Do you know what I'm saying? Alright, so as I rotate it, I'm going to figure out how many times does it match up exactly. So rotate, nope. 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 Yep. Rotates once. Twice. 3 times. And then it rotates right back on itself 4 times. And that's when I'm going to stop because my top is back at that position. So how many times did this rotate? 4. So 360 divided by 4. What's my rotational symmetry? What is my magnitude going to be? 90. 360 divided by 4 is 90 degrees. Okay, if you want to visually write that in there, because if you're looking at this and you're like, how the heck did I get this? You might think that it rotated here, 2, 3, 4. Okay, so using that patty paper can be really helpful while you do this practice. So if you need more patty paper, I have more. I'll put it up front, and you can always use that. Your practice today is a front and back side. It's very similar to this. You're going